So in our first video, we looked at arithmetic sequences and how they apply to direct variation and how we can check if it is direct variation or if it's proportional. Remember that direct variation and proportional are directly linked. So let's look at another sequence. We'll consider this one and maybe learn a little bit more. I'll teach you another way to check out how something is direct, whether it's direct variation or not. Okay, so let's go ahead. Let's check what would the next three numbers be. Figure it out. Hopefully you recognize that I'm adding 2, adding 2, adding 2, so it would be 5, 7, and 9. Okay, so let's go ahead and plot these again. So remember last time we talked about, remember this is our constant difference. So we do have a constant difference. I'm just going to label as constant difference equals positive 2. Okay, remember last time we did an x and a y. We did the first term, the second term, the third term, the fourth term. We'll go up to the fifth term. The first term being negative 3, second term being negative 1, 1, 3, and 5. We'll go ahead and plot these. So the first term being negative 3, the second term being negative 1, the third being 1, the fourth being 3, and then the fifth being 5. Okay, now hopefully you can see that these lie along a straight line. So we can draw the line that connects those points. Okay, so from this we learned something. If we put this with the last one, we recognize that if there is a constant difference, then the graph will be linear. Okay, so if there's a constant difference, it's linear. But does having a constant difference make it direct variation? Well, if you look at our graph, you can probably see very clearly that this is not direct variation. Okay, you can check that without graphing as well. In our last one, we learned that the constant difference was also equal to the slope. Okay, now if we want to check whether this is direct variation or not, then what we can do is we can use the direct variation equation. What is the equation for direct variation? Hopefully you remember that it's y equals kx. Alright? Now k, remember, is the constant of variation, which is the same thing as the slope, right? And so we can put that in. We can say y equals 2 times x. So this is what it would have to be if it were direct variation. So let's check. Take any one of your points. Doesn't matter which one. Take any one of those points and plug it in. Okay? So let's, just for the sake of it, take the first point. So that's negative 3 equals 2 times 1. And you get negative 3 equals 2. Obviously, that is not true. Therefore, it is not direct variation. We checked it by the graph. You can check it by the slope, down 2 over 1. That's definitely not passing through 0, 0. We've checked it by looking at the direct variation equation as well. Okay, so those are all ways that we can look at and then consider whether something is direct variation or not. Is it in an arithmetic sequence? Absolutely, because it has a constant difference of 2. Is it direct variation? No. Is it linear? Yes. All right, so I'm going to go ahead and stop this one. Go ahead and move on to the next video.